Hello students, this is our first video on geometry. So in this video I'm going to review some geometric formulas, things you've probably seen before, just kind of highlight a few important facts to kind of keep in mind when you're solving problems, and kind of give you the basics we need to go on to solving the more advanced geometry problems that we're going to do in the next video. So we're going to talk about calculating kind of three different things. So area, perimeter, and volume. And we're going to talk about them for a variety of kind of different shapes. So I want to start off by talking about circles. And I just want to review some terms. So obviously you all know what a circle is. So just some measurements that we use with circles. So starting off with what's called the radius. So the radius is the distance from the center of a circle to the edge, okay? This is not to be confused with the diameter, which is the distance all the way across the circle, okay? So most of our formulas involving circles use the radius, just because that's what people do. A lot of times problems, though, will be phrased in terms of diameter. So, of course, if the radius is the distance from the center to the edge, the diameter is the distance all the way across. The radius is 1/2 of the diameter. Okay? So in general, if you want to solve a problem, if you're given the diameter, divide that in half to get the radius. Make sure you just notice to do this. Okay, so I'm assuming most of you probably know what a diameter and a radius are. Make sure you think about this. If the problem gives you the diameter, don't accidentally use it as the radius or vice versa. Okay, so don't get tripped up by that. So in terms of the circle, using the radius, we can find both the perimeter. So I'm going to call this the perimeter. It's also called the circumference. So circumference is just a fancy word for the perimeter, the distance around the edge of the circle. It's the same thing. Okay, so circumference is just the perimeter of a circle. So the perimeter or circumference of a circle is 2 times pi times r, right? Remember pi is this number, 3.14159, etc. You can use the button in your calculator or whatever. The area of the circle is going to be pi times r squared. So you take pi times the radius squared. So r here is the radius in both cases. So 2 times pi times r will give you the perimeter. Pi times r squared will give you the area. Okay? So pretty basic. Just use those formulas to find the perimeter and the area of the circle. Okay? Next thing, rectangles. So again, just kind of reviewing some of these formulas that you've probably seen before but maybe haven't used in a while. So a rectangle has length and width. Okay? If you want to find the perimeter, the distance that it takes to go all the way around the rectangle, you're going to take length plus width plus length plus width, right? Because you want to go all the way around. Or if you want to write that down, that's 2 times the length plus 2 times the width. So L here is length, W is width. So perimeter is 2L plus 2W. The area, even easier, is length times width. Okay? So again, very familiar, but just to review these are the ones that you need to know, that you'll need to be able to use. Okay? Last two-dimensional shape I want to talk about is the triangle. So again, just basics. So triangles We've got three sides, which I've labeled with A, B, and C. And then we've got the height of the triangle, which is the distance from a point on the triangle to the opposite side. It doesn't actually matter which one you use, but we'll refer to the base as the side that we're going to, and the height as the distance from the opposite point to that base. In this case, your perimeter is just going to be the lengths of the sides added together, and your area is 1/2 times the base times the height. Okay? So these formulas are pretty basic. When we start to get into three-dimensional shapes, the formulas get a little bit more complicated. Okay? So I'm assuming you've all seen these, you've used these many times. Just wanted to review them real quickly. Let's look now at three-dimensional shapes, which are a little bit more complicated. So for a, we're going to start off with a three-dimensional shape. So what's called a rectangular prism is the mathematical term for it, but a lot of times we're just going to call a box. So this is something, a shape, which is rectangles on each side. Okay, so it's a rectangle on every side. So a box is an example. Anything that is rectangular on each side. Okay, so this is a pretty easy shape to understand. It's got three measurements which are important. It's got a length, it's got a width, and it's got a height. Okay, so length L, width W, height H. And in 3 dimensions, we're interested in two kinds of measurements. So we can talk about area, what's called the surface area, and that's going to be the area of all of the different sides of this shape. Okay, so the surface area is the area of all 6 sides of this particular shape. In this case, kind of the same idea as perimeter was, where you take the area of each side and add them together. Okay? And so if you think about the 6 sides of this shape, you've got this front piece, which is length long times height high, and you've got a back piece that matches it. So you've got a length times height in the front, a length times height in the back. So you're going to have 2 length times height for the front and the back. On the side, you're going to have height times width for this side and also for this side. So you're going to have 2 times height times width. And then you're also going to have the top and the bottom, which both have area length times width. So 2 length times height plus 2 height times width plus 2 length times width is going to be the surface area, the area of the entire box. Okay? The other measurement we're interested in, what's called the volume, is going to be length times width times height. And that one you've probably seen many times. So to find the volume, you just multiply the length times the width times the height. Okay? So that's a rectangular prism. Last shape that I want to talk about is a cylinder. Okay, so a cylinder, and so this is probably a familiar shape. So a cylinder is like a circle, but then with some height, right? So anything in the homework, you'll see some examples that are like round cakes. Pipes are examples of cylinders. Anything like that that's circular in cross-section and has some height. So this is going to have kind of 2 important measurements. So the radius, r, or you might be given the diameter, in which case you would divide it in half to get the radius. And then also the height, h. Okay? Are the 2 important measurements for a cylinder. And from this, you can get both the surface area and the volume. Okay? Now surface area is, I'll write down the formula and then I'll explain to you a little bit of where it comes from. It's a little bit confusing. But the surface area is going to be 2 times pi times r squared plus 2 pi r h. Okay? And so where this comes from, if you think about this shape, it's got 3 sides to it. There's the top and the bottom, and then there's this vertical side, right? The top and the bottom both have area pi r squared because they're just circles, right? So 2 pi r squared, that's the top and the bottom added together. Pi r squared plus pi r squared gives you this piece. The 2 pi r h is the area of this collar around the outside edge, okay? And where that comes from, if you think about it, if you unrolled, say you cut this cylinder down the edge and unrolled it, you would get a single rectangle. It would have height h, right? Because it would, if you, along that cut, it would measure h. And then if you think about the length of the other side, it would be this length, starting here, going all the way around the circle. And that's the circumference, the perimeter of the circle, which is 2 pi r. And so that's where the 2 pi r h term comes from. Okay? So that's the surface area. The volume is a little bit easier. So the volume is just pi r squared h. And that's because if you think about taking the area of the top and then multiplying it by h to get the entire volume, just like we did with rectangles. Okay? So that one's pretty easy to understand. Okay? So let me just walk you through one more thing before I finish this lecture, and that's actually using these formulas and kind of making sure of one thing that's super important. So this is, I just want to make a point with this. So I'm going to use this volume formula for a cylinder, and I want to work through a problem with it. Okay? So I'm going to leave this up here, volume equals pi r squared h, just because I want to make an example. So say you have a cylinder with diameter 4 inches and height 3 feet. Okay? What's the volume? Okay? Now we know the formula is volume equals pi r squared h, and so it's very natural to say, okay, I'm going to take volume equals pi times 4 squared times 3. And that's wrong, like 100% wrong. Okay? And there's 2 things that are wrong with that. For one thing, this 4 inches is not the radius, it's the diameter. Okay? So here we have a radius, r equals 2 inches. Okay? The other thing is we need to be careful to make sure that all of our measurements are in the same kind of units. Okay? So you can't say that it's 2 inches squared times 3 feet. If we did volume equals pi times 2 inches squared times 3 feet, our answer, which would be something like, excuse me, 18, or no, no, more than that, 36, somewhere around there, would have units inches squared times feet. Okay? And that's no good. You don't want units of inches squared times feet. So you need to convert one of these into either they both need to be in inches or they both need to be in feet. I'm going to convert 3 feet into inches. It's a little bit easier. And 3 feet, each foot is 12 inches. right? So 3 feet times 12 inches per 1 foot, right? Our dimensional analysis from before gives us 36 inches. And so rather than 3 feet, we'll use 36 inches here. And then we can do pi times 2 squared, which is 4, 144 times pi. And our units here, inches, 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 gives us cubic inches. Okay? So make sure everything's in the same units before you put them in the formula, or otherwise you're going to get yourself into trouble.